Hi everyone, today we want to learn mapping soil salinity with Landsat data. Soil salinity is a major environmental issue that affects agricultural productivity and can lead to desertification, particularly in a region with a scarce freshwater resource like the Pakistan. And high salinity level reduce the soil fertility, restrict the plant growth and make it difficult for farmers to grow crops. Monitoring soil salinity is crucial for managing the water resource, improving agricultural yields, and maintaining ecosystem health. In remote sensing, the Soil Salinity Index or SI is a commonly used proxy to identify areas with high salinity levels, and the index uses the shortwave infrared, SWIR, and near infrared bands of a satellite imagery. And these bands are sensitive to moisture levels, and their reflectance properties change in a saline condition. And the formula for calculating the soil salinity index SI is SWIR1 subtract the near infrared divided SWIR1 plus near infrared. SWIR band 6 shortwave infrared band which responds the moisture content in the soil. Near infrared band 5 which help to detect healthy vegetation. The resulting soil salinity index helps to highlight the areas with the varying salinity levels where higher values indicate higher salinity. Surveyor and near-infrared response to soil salinity. The reflectance of soil and vegetation in surveyor and near-infrared bands is influenced by the moisture content and saline source. The moisture levels are higher to the salts absorbing the water and resulting in the different reflectance characteristics. And the soil salinity index uses this band to detect these changes. We use the two color composite from the Landsat data, and we have different application in agriculture, water resource management, and land management from these steps. In the step-by-step implementation, we define the area with the geographical region of interest. In the case we are focusing on the Indus Basin, Pakistan, which is located between this latitude and longitude. And if we run this, zoom in these areas, and we define the data range, we selected the 2024. We loaded the Landsat data from image collection. If you want to study more, you can find this data set from the Earth Engine data catalog available from 2013 to 2025 with a revisit of 16 days. You can find the more description here, the bond name, the pixel size, wavelength, and description of the bonds. And we use it to filter the collection based on area of interest and date range, and additionally we filter out image with more than 20% cloud cover. So in here, the filter bonds restrict the data to define area of interest, filter date, start date, interest, in date, limit the data to chosen time period, and filter the cloud cover, ensure that the cloud cover is less than 20%, and median, calculate the median value of the image collection to reduce noise and cloud cover, and clip area of interest, clip the final image to the specific area of interest. And in other step, we need to add a scale factor. We have a scale factor in the Landsat data is already corrected for atmospheric effect, but it's need to be scaled using the specific scaling factors. Here we apply the scaling factor for each of the bonds, and we are interested in the red, green, blues, and near infrared and SWIR bonds. And we use it to multiply with this number and add minus 0.2 to scale factor for the Landsat A surface reflecting response. And in step 5, we calculate the soil salinity using the SWIR bond 6 and near infrared bond 5. with this formula, and after this we going to create the two color composites, the red bond 4, green bond 3, and blue bond 2. And after this define the resolution parameter. We define the resolution parameter for both the soil salinity index and two color composites. Salinity resolution uses the color palette ranging from green, low salinity, to red, high salinity, and two color resolution adjust the scale for displaying the two color composite. And after this, we can add layer to the map. We have a two index and two resolution, and we added the layer name. You can see we have two colors and soil salinity index. In agriculture and vegetation area, we have a low soil salinity, but in a desert area, we have a high soil salinity index, and you can use this in any area of interest and any time you want. If you're interested in the soil salinity index, you can watch a video about the soil salinity from a Sentinel-2 and MODIS satellite. And thank you for your watching and subscribing our channel.